In this video, we will study two colored balls permutation without replacement and with sampling of 3. An urn contains 12 blue balls and 8 red balls. 3 balls are picked up at random without returning the balls to the urn. First question, what is the number of all possible outcomes or the number of elements in the sample space? The first thing we do, we number the balls. So we number the blue balls from 1 to 12 and the red balls from 1 to 8 to make them distinguishable, or we number all of them from 1 to 20. So let us first examine the drawing process. We may get balls number 11, 9 and 6, or balls number 6, 11 and 9. So that means the ball come out of the urn in order, and the sample space is composed of ordered elements. So the outcome of the probability experiment is ordered and without replacement, and the probability of any event in the sample space must be solved using a formula which requires order and no replacement, and this is the permutation formula which can be used under these two conditions. So the number of elements in the sample space for the case of order can be computed from the permutation formula under the condition of withdrawing without replacement. We have the number of population n is equal to 20 and r the sampling size equal to 3. We are picking 3 objects out of population of 20, so we substitute that in the permutation formula, n with 20 and r with 3, and we get 20 times 19 times 18, and this is equal to 6,840 possible outcomes. Question number 2. What are the possible joint outcomes from the standpoint of colored balls? So let B represent drawing a blue ball and R represent drawing a red ball. We started drawing the tree diagram with 12 blue and 8 red. So for the first draw, we may pick 1 blue or 1 red. If we pick 1 blue, then we have 11 blue remaining out of 12, and if we pick 1 red, then we have 7 red remaining out of 8 red. For the second draw, we may pick again blue or red after blue, or blue and red after red. But the remaining blue balls after picking 1 blue will be 10, and the remaining red balls after picking 1 red will be 6. For the third draw, we may pick again blue or red, and the remaining blue balls will be 9, and the remaining red will be 5. And now we can get all the possible joint outcome by following each path. So in this path here we have a blue, red and blue, and in this path here we have red, blue and red, and so on. So we have 8 possible joint outcome. So let us isolate all the joint outcome and put them in order, turn them around and put them in the sample space. So now we created partition in the sample space, and we have to name each event. So this event is picking first red and second blue and third red, and this event here is picking first blue, second blue and third red, and so on. Question number 3. How many 3 blue balls can be withdrawn? So we are picking out of the blue set the first blue, the second and the third, and now we sampled 3 objects. So the number of ways of picking 3 blue out of 12 is 12 permuted 3 at a time, and this is equal to 12 times 11 times 10. So we have 1320 possible outcome to pick 3 blue at a time out of a set of 12 blue. Question number 4. How many first red, second blue, and third blue balls can be withdrawn in order? So here we have all the set, and we pick first red, and second blue, and third blue. And now we have a sample of 3 objects. So we need to pick first red, and second blue, and third blue. So to pick first red, we are picking 1 red out of 8, and that is 8 red permuted 1 at a time. And then we are picking 2 blue in order out of 12 blue, and that is 12 blue permuted 2 at a time. Now we need to pick red and 2 blue in order, so we multiply 8 red permuted 1 times 12 blue permuted 2 at a time, and this is equal to 8 times 12 times 11, 1056 possible outcome. Question number 5. How many first blue, second red, and third blue balls can be withdrawn in order? So first we are picking 1 blue, and second red, and third blue again, and now we have a sample of 3 objects. So we need to know the number of ways of picking blue, red, and blue. So first we are picking blue. We are picking 1 blue out of 12, and that is 12 blue permuted 1 at a time. And secondly, we are picking 1 red out of 8, and that is 8 red permuted 1 at a time. And thirdly, we are picking blue again, but out of 11 blue, because already 1 blue is picked before. So we are picking 1 blue out of 11, and that is 11 blue permuted 1 at a time. So now to know the number of ways of picking blue, red, and blue, we use the multiplication principle. We multiply them together, and we get 12 times 8 times 11, and that is 1056, which is exactly the answer we got before. So this is the answer we got before for the case of red, blue, and blue. And the reason why we solved the question for blue, red, and blue is to emphasize on the order of picking and the order of product. We use the multiplication principle for the case of order in order to show the difference between the 2 cases, even though the final answer is exactly the same. Question number 6. What are the probability of each disjoint event in the sample space? So back to the sample space with all the events in it stated in the order of picking. So far we found the number of ways of picking these 3 events, and that is 3 blue, 1 red and 2 blue, blue, red, and blue. So we can keep doing that. For example, for this event, picking blue and then red. So first we are picking 12 blue, and second we have 11 because it's withdrawal without replacement, and third we are picking 8 red. And for this event again we're picking 12 blue, and then 8 red, and after that 7 red. We keep doing that. For this event we are picking 3 red, so in the beginning we pick 8, and then after that 7, and after that 6, and now we have all the possible outcome for each event in the sample space. So to find the probability of each event, we divide each favorable outcome over the number of elements in the sample space. So we do that for this event, and then for these events, and we continue until the last one. So this is the probability of each event in the sample space written as a fraction. Now we compute the numerator and denominator and substitute, and we get these probabilities, remembering that the number of elements in the sample space is 6840. Question number 7. What is the probability that the first and the second balls are blue? So back to the sample space, we have this event, the first blue and the second blue, and we have this event, the first and the second blue. So we add the probability of these two events together, and we get 0.34. Question number 8. What is the probability of picking 2 blue first or 2 red first? So back to the sample space, picking 2 blue first, so here is 2 blue first, and in this event also we have 2 blue first, or 2 red first. So in this event we have 2 red first, and in this event we have also 2 red first. So we add the probabilities together, and we get 0.49. Question number 9. What is the probability of picking 1 red only? So in the sample space we have 3 events, and each one has 1 red only. So these are the events. They are disjoint event. So the probability of the event picking 1 red is the sum of the probability of each of these events. So we substitute, and we get 0.46. Question number 10. What is the probability of picking first red and second blue? So here is first red and second blue, and this event has first red and second blue. So we have 2 events only, and they are disjoint event. So the probability of picking first red and second blue is the probability of this event or the probability of this event, and they are disjoint, so we add their probabilities together, and we get 0.25. Thank you for watching, and have a nice day.